All right, Honors Algebra. Today we're doing section 10.2, which is simplifying radicals. There's kind of a lot of rules to radicals, so make sure you read all of the rules, all right, in the section. Make sure you read the section and look at my notes that I post. All right, I'm going to be doing the first 6 problems on page 623 because those 6 problems will basically cover all of the different rules of simplifying radicals. Okay, so the first one, all right, number 1 says the square root of 98. All right, the square root of 98. Now, when we simplify radicals, we can't end up with decimals, okay? So you can't just take your calculator and plug in the square root of 98, and come out with 9.899, all right? We need to figure out exactly what numbers can we pull out of the square root. So what we're trying to think of is a number that is a perfect square. And when I mean it's a perfect square, it's a number like 64, where if you take the square root, then you get a whole number, so 8, or like 36. All right, 36 would be a perfect square, all right, because the square root of 36 is 6. All right, so we need to find a perfect square, a number like that also goes into 98. And we can rewrite this. Instead of writing it as the square root of 98, all right, I'm going to rewrite this as 49 times 2. Because isn't 49 times 2, isn't that just 98? All right? And look at what I have here. I have a perfect square number, all right? So this can also be written as the square root of 49 times the square root of 2. And I'm not saying that you have to do all of this work, all right? I'm just showing you how to break it down so it looks a little bit easier. And then your final answer here, what's the square root of 49? That's 7. And you can't do anything with the 2, so you just leave it inside of the radical. So simplifying the square root of 98, I would say my answer is 7 root 2. All right? So you're going to want to get a lot of practice doing that. Okay? Number 2. All right, number 2 says the square root of 16b to the 5th. Now, just like this problem over here, I'm going to break up my square root into something that looks more like this. So can't I just rewrite this as the square root of 16 times the square root of b to the 4th? You always want to take your exponent, the exponent that they give you. If it's an odd number, then bring it down to the closest even number. Aren't these two things just the same thing? All right? Square root of 16, there's my square root of 16. And then b to the 4th times b is b to the 5th. But I broke it down like this because what's the square root of 16? That's 4. What is the square root of b to the 4th? That's b squared. And then what do I have left over? Square root of b. So my final answer would be 4b squared times the square root of b. All right? All right, let's do another problem. Number 3. All right, number 3, we have 3 root 5m times 4 root 1/5 m cubed. All right, this might look kind of messy, but it actually isn't. All right, so here's another rule that they want you to learn. You can only multiply numbers that are outside of the radical together. You can only multiply those numbers together, and you can only multiply numbers inside of the radical together. So if I multiply these together, I'm going to say 3 times 4, which is 12, okay? And I can't move that 12 inside of a radical, but everything that's inside the radical up here, I can multiply together. So what is 5 times 1/5? That's just 1, right? And then m times m cubed is m to the 4th. So all I'm doing is taking, what is the square root of 1? Well, the square root of 1 is 1, right? So I have the square root of 1 is 1, and the square root of m to the 4th is m squared. So 12 times 1m squared is just 12m squared. So it starts out messy and then ends up being real nice. Okay? All right, let's do another one. Number 4. Number 4 says the square root of 15x all over x cubed. All right, well, and because we're working underneath a radical here, can't I just cancel this x with one of these x's, right? So now my new problem is the square root of 15 all over x squared, all right? And what is the square root of x squared? That's just x. Can you break the 15 down any more? Can you pull out any perfect squares? And the answer is no. So you just leave it like this. The square root of 15 over x. Remember, because the square root of x squared got me the x. All right. All right, so let's do another one. Number 5. The square root of 5 all over the square root of 3. Now, you might be looking at this saying, well, I can't do anything with this. This is done. All right, I can't find any perfect squares in either the 5 or the 3, considering they're prime numbers. All right, the thing is, though, the rule for radicals, you cannot have a radical in the denominator. All right, you cannot have a radical in the denominator. So what you have to do is multiply the numerator and the denominator by whatever's in the denominator, square root of 3. And the reason that I can do this is because the square root of 3 over the square root of 3, that's just 1. The multiplication property of 1 says that I can multiply anything by 1, and it doesn't change my problem. All right? And so, if I continue this problem, the square root of 5 times the square root of 3 will give me the square root of 15. And then in the denominator, the square root of 3 times the square root of 3 is the square root of 9. And what is the square root of 9? It's just 3. That's kind of a rule of thumb. If you multiply the exact same square roots together, so like square root of 4 times the square root of 4, the answer is 4. The square root of 100 times the square root of 100, the answer is 100. You know, the square root of Luca times the square root of Luca, the answer is Luca. All right? Square root of big tuna times the square root of big tuna is big tuna. You get the exact same thing underneath the radical. All right, so here's my final answer, the square root of 15 over 3. All right, and then the last one, all right, number 6, it says the square root of 6 all over the square root of 2n. All right? So once again, you can't have the radical in the denominator. So we have to take care of that. All right? Once again, I'm going to multiply by the square root of 2n all over the square root of 2n. So if I do that, I get 6 times 2n, which is the square root of 12n. And then in the denominator, remember I said before, if you multiply the square root of 2n times the square root of 2n, I'm just going to get 2n. Okay? That's why this works. That's why you have to do it this way, to get rid of that radical. All right, now I need to break down this numerator because 12 has a perfect square in as a multiple. All right, remember it's 4. So I'm going to break the numerator into the square root of 4 times the square root of 3n, which if I just multiplied those together, I'd get 12n, so that's okay. And then what is the square root of 4? That's just 2. And I have one more step. The 2's cancel. So I'm left with the square root of 3n all over n. And now you might be asking, why can't I cancel the n next to the 3 and the n down here? Well, it's because the n next to the 3 is still in a radical. All right, it's connected to that 3 inside of this radical, so I can't pull it out of the radical and cancel it with this n. So this is my final answer. All right. So hopefully all these rules and all these examples will help you with the homework. All right, hopefully everyone's staying healthy and safe. Miss you guys.